For as long as humans have looked up at the stars, we've wondered, are we alone? But the search for extraterrestrial intelligence, SETI, while it isn't just about pointing telescopes at the sky, it's a question that reaches back to some of our oldest human curiosities.
That's absolutely right. It connects really deeply with our desire to understand the, faraway peoples, distant times, even lost civilizations right here on Earth. The challenge of understanding something vastly different from ourselves, separated by, well, immense distances and huge stretches of time.
Exactly. And that's why today we're taking a deep dive into how fields you might not immediately think of with aliens, archaeology and anthropology, actually offer some incredible insights into the search for cosmic neighbors.
Yeah, we're going to explore how studying human history, our cultures, ancient artifacts, how they can genuinely help us think about the profound challenges of, well, encountering beings potentially unimaginably different from us across light years.
We're drawing our insights today from a really fascinating collection of research. It's in a book called Archaeology, Anthropology, and Interstellar Communication. And our mission really is to pull out the most surprising connections and maybe the most important lessons these fields hold for SETI.
Like, why might decoding an alien message be kind of similar to deciphering a dead language?
Right.
Or what can past human encounters, here on Earth, teach us about the potential outcomes of some kind of cosmic first contact?
Let's unpack this then. Where did the modern sort of scientific search for ET intelligence even begin?
Well, you can trace the modern effort back to 1959. That's when Giuseppe Cocconi and Philip Morrison published this paper suggesting we should listen for radio signals from other stars at a very specific frequency, the frequency of neutral hydrogen.
Okay, right. The idea being that any advanced civilization might think that frequency is just a logical place to look or maybe to transmit from.
Precisely. And building on that, just a year later, 1960, the radio astronomer Frank Drake conducted the very first actual search, which he called Project Ozma. It only targeted 2 stars, mind you.
Wow, 2 stars.
Yeah. And then the next year, 1961, he famously came up with his equation, the Drake equation, which tries to estimate the number of communicative civilizations out there in our galaxy.
So very early days then, a mix of theoretical ideas and ambitious but pretty small-scale searches. What about NASA? When did they get involved?
And NASA did get involved, yes. Starting around the mid-1970s, they began funding definition studies. People like John Billingham at Ames Research Center, he was a key figure. There was even this huge design study back in '71, Project Cyclops, that envisioned a massive array of telescopes just for SETI.
A grand vision. But SETI's history is also marked by struggle, isn't it? It wasn't all smooth sailing.
Oh, absolutely not. Despite the scientific rationale and all that planning, SETI consistently faced, really low funding levels and a lot of skepticism. Do you remember Senator Bryan asking about searching for little green men?
Yeah, I do. That kind of comment.
Exactly. It reflected a broader view, one echoed by some scientists too, like Ernst Mayr, who basically argued the probability of success was just vanishingly small.
And that skepticism had real consequences, right? NASA's formal program, the High-Resolution Microwave Survey, HRMS, that launched in '92.
Yeah, it launched on Columbus Day 1992. It was planned as this decade-long effort, but then Congress just abruptly canceled it only a year later in 1993.
Just like that. Wow.
It was a huge blow. But, the search didn't actually stop. It carried on, thankfully, thanks to private funding through the SETI Institute. And they fittingly named their privately funded effort Project Phoenix, kind of rising from the ashes.
That story really highlights the resilience of the people involved, definitely, but also just how precarious SETI has often been. And it all circles back to the core challenge, which the sources really emphasize.
Yes, the fundamental reality of standard SETI is just the immense distance involved. Yeah. I mean, we're talking trillions of miles. Even a signal zipping along at the speed of light takes centuries, maybe thousands of years, to cross that gap.
Which means any message we might receive is likely ancient history from the sender's perspective. And if we tried to reply...
our response wouldn't arrive for millennia.
Great.
Exactly.
Okay.
So interstellar communication, as we currently understand it anyway, is almost certainly a one-way transmission. You're receiving a message, basically an artifact, from a potentially long-gone civilization. There's just no quick back-and-forth dialogue possible.
Okay, so if we receive something, it's kind of like digging up an ancient artifact from some lost civilization here on Earth. That's where archaeology comes in, right? That's the link.
That's the powerful analogy the source material makes, yeah. Archaeologists are experts at reconstructing entire civilizations, their beliefs, social structures, technology based on really fragmented evidence left behind, like pottery shards, ruins, maybe some texts. A SETI scientist analyzing a signal might be doing something remarkably similar for an alien culture.
And figuring out what that signal means. Ben Finney and Jerry Bentley in the book suggest we can learn some crucial lessons by looking at human history specifically, how we've really struggled to decode dead languages right here on Earth.
This is where it gets really fascinating. Take Egyptian hieroglyphs. For centuries, scholars were just stuck because they believed in what's called the ideographic myth, this mistaken idea that each hieroglyph represented some pure concept or idea, totally disconnected from spoken language.
Right, like a picture of a bird just means bird conceptually, not a sound or part of a word.
Exactly. And Michael Coe, who's an expert on ancient scripts, explains how this myth basically paralyzed decipherment for centuries. You had people like Athanasius Kircher making these wild, elaborate interpretations, essentially just making things up, because they didn't grasp it was a complex writing system tied to grammar and sound.
And it wasn't just Egypt, right? The Mayan glyphs were similar.
Yeah, the same kind of assumption held back the decipherment Mayan glyphs for a long time, too. It really wasn't until researchers figured out they were a mix of phonetic and logographic elements tied directly to the spoken Mayan language that real progress was made.
So the big takeaway here seems to be, assuming an unknown script or an alien message is just pure ideas and not tied to something specific like language or some other arbitrary convention they have, well, that's a recipe for getting completely lost.
Absolutely. I mean, deciphering a message from a totally alien mind, one that doesn't share our biology, our history, our sensory world, maybe not even our fundamental cognitive structures, that's going to be exponentially harder than cracking Egyptian hieroglyphs.
It really challenges that maybe optimistic idea that if aliens send us a message, it'll automatically be understandable just because they want us to understand it. What if the key or the shared context is based on something completely alien to us?
Well, people have proposed creating artificial languages specifically for interstellar messages based on supposedly universal principles like logic, math, physics. Hans Freudenthal's Lingua Cosmica, Linkos, that's a famous example.
The thinking being, okay, any civilization advanced enough to send a signal must understand physics or math, so that's our common ground.
And look, it's a valid starting point. But the sources rightly question whether these are truly universal, or are they just human ideas about what universality looks like? We might still be injecting our own assumptions about how intelligence works or, what's important.
The sobering lesson archaeology offers seems pretty clear then. Deciphering even human languages without keys, like the Rosetta Stone or parallel texts, is incredibly difficult. It often takes generations. We need to be really cautious about assuming that decoding an alien message, no matter how well-intentioned the sender was, is going to be easy. Whole layers of meaning might just remain completely opaque to us, possibly forever.
So if deciphering the message is one huge challenge, understanding the beings who might have sent it is another kettle of fish entirely, which is where anthropology steps in.
Right. Anthropology, the field dedicated to understanding the dizzying diversity of human cultures. The other, right here on our own planet. John Traffigan and Douglas Raybeck argue its frameworks are really invaluable for thinking about potential extraterrestrial civilizations.
They talk about this concept of anthropology at a distance. A classic example that often comes up is Ruth Benedict's study of Japanese culture during World War II. She couldn't go there, obviously, so she studied it from afar, mostly through interviews with Japanese Americans.
Wow, that sounds incredibly challenging. Trying to grasp a whole culture without being there.
It absolutely was, and the source points out the limitations, the potential inaccuracies in her work, precisely because she lacked that immersive experience. Yet her study significantly shaped Western understanding and misunderstanding, perhaps, of Japan at the time. It's a powerful, if cautionary, analogy for how we might have to approach understanding an ETI from an immense distance with probably limited data and potentially significant blind spots.
That makes a lot of sense. And anthropologists themselves have wrestled with a really fundamental question. What even is culture?
Well, it's a concept the field has debated endlessly. The sources highlight a big shift away from an older view of culture as this static, bounded, uniform thing shared by a group, almost like a fixed blueprint for behavior.
Sort of like, this is the culture of Group X, as if it's one solid block.
Exactly. But the more contemporary view, as people like James L. Watson and John Traffigan discuss, sees culture as far more fluid, constantly being negotiated, contested even, and ultimately an individual process of organizing experience and memory. It's less a static thing and more a dynamic personal process that shapes how you see the world.
Okay, so if human culture, even within one society, is that complex, fluid, and varied, well, imagine how much more diverse, contested, maybe non-uniform, an alien culture, or whatever their equivalent is, might be. This really complicates the idea that all individuals from planets.
Feedback takes this anthropological lens and applies it by looking at Earth's own history of cross-cultural encounters as potential, maybe rough analogies for ETI contact scenarios.
Her own history is certainly full of those encounters with incredibly varied outcomes, unfortunately.
Right. You've got cautionary tales like, say, China's isolationism, which arguably led them to underestimate Western powers when they arrived. Or the really tragic example of the Spanish conquest of the Aztecs, where existing divisions within the Aztec world were actively exploited by the conquistadors.
Devastating outcomes, yeah. But were there examples of maybe more effective responses in our history?
Raybeck points to some, like the Maori in New Zealand, their really strong, organized resistance to British colonization, while ultimately facing huge challenges, did earn them a degree of respect and help preserve aspects of their identity, even as things changed drastically.
Okay.
Or maybe the Iroquois Confederacy in North America. They were known for being very adept at selectively adopting European technology, things like firearms when it suited them, but they largely resisted cultural assimilation for a significant period.
Those are fascinating contrasts. So, the lesson from Earth history seems to be that while there's no single right way to respond when you encounter a vastly different, potentially technologically superior group, some approaches might have been more effective at preserving identity or achieving a, let's say, less catastrophic outcome.
Precisely. And Raybeck goes a step further. He suggests that maybe a society with what he calls balanced heterogeneity, meaning diverse peoples, where no single group is consistently privileged or disadvantaged, might be better equipped mentally, culturally, to navigate and respect profound differences when encountering something as fundamentally other as an ETI.
It's like the ultimate test of a society's ability to deal with difference, isn't it? And as Alvin Toffler apparently noted in the sources, just contemplating alien cultures forces us to look inward, to really examine our own deeply ingrained cultural assumptions. The hypothetical alien perspective can be like a powerful mirror, offering new insights into human cultures.
Which brings us back around to communication. If we ever decide, okay, we're not just going to listen, we're going to send a message, what on earth should that message be?
Historically, SETI was mostly passive SETI, just listening. And there was significant caution, right, even within NASA back in the mid-'80s, about active SETI, or METI, actually transmitting from Earth. The concern, quite understandably, was about potentially exposing Earth to hostile aliens. Don't shout in the jungle, as some say.
Yeah, there are strong arguments for caution from figures like Michael Michaud, Dan Werthmer, David Brin. They basically argue we should listen for a long time, maybe centuries, before even considering transmission. Because while some argue that really advanced societies might tend towards being peaceful and cooperative to survive long-term, well, that's just a probabilistic argument, isn't it? Not a guarantee.
On the other hand, though, as Frank Drake pointed out ages ago, we're kind of already broadcasting our presence, aren't we? Through powerful radar and TV signals that have been leaking out into space for decades now, the genie might already be out of the bottle.
That's a fair point.
And Donald Targer raised another interesting idea. What if aliens send us a deliberate signal? If we just sit here and don't reply, could that be seen as an insult? Or maybe hostile indifference? He suggested maybe a preemptive acknowledgement is necessary.
It's a really complex debate with no easy answers. But we actually have historical examples of humanity trying to communicate across vast time and space, even if not specifically targeting aliens.
You mean things like time capsules, that sort of thing?
Exactly. Remember the Keo satellite project? Now, it wasn't ultimately completed, but the concept was fascinating. It was designed as this time capsule to orbit Earth for 50,000 years, intended for future humans, or maybe whoever might find it long after we're gone.
What was it supposed to carry?
It was meant to carry digitized messages from basically everyone on Earth who wanted to contribute, a sort of Library of Alexandria of current knowledge, DNA samples, an astronomical clock.
Albert Harrison points out in the source that projects like Keo, even just the planning, reveal a lot about what humanity, or at least parts of humanity, values and wants to convey across time or to a distant recipient.
Then you have more direct attempts at messaging, reflecting maybe a broader range of human expression. In 2008, there was this project called A Message from Earth, sent towards Gliese 581z, a planet that looked kind of promising back then. It was based entirely on public submissions via a social networking site, Babo, I think it was.
Okay, so what did people send? Was it all scientific diagrams and prime numbers?
Not exactly. It was a real mix. There was text, drawings, photos reflecting everyday lives, people's ambitions, landmarks, but also things like political candidates and pop culture figures got included.
Wow. Okay, that's a far cry from just sending math equations, isn't it?
Definitely. And then, even more commercially, in 2010, Penguin UK apparently transmitted some short messages towards the Orion Nebula as part of a book promotion. Things like, "Did you think you were alone?" Or, "We don't bite, do you?"
Wow. Huh. So these real-world examples show that when you open it up, humanity sends this, well, eclectic mix of the profound and the mundane, the scientific and the deeply cultural, even the commercial. It really contrasts with those more formal proposals, based purely on supposedly universal physics or logic.
And William Edmondson, in The Source, talks about the serious constraints on designing messages for a truly alien intelligence. He argues you simply can't rely on language or arbitrary symbols because there's absolutely no shared context. Zero.
Right. No Rosetta Stone waiting for us out there. We can't assume one.
Exactly. So he suggests messages must be based on principles that might genuinely be universal, like physics, perhaps, or maybe something tied to perception, like vision, assuming they have something analogous. He proposed a kind of postcard Earth, maybe a visual collage.
And didn't you say people involved in that Earth Speaks project independently came up with similar visual ideas?
They did, yeah. Suggesting pictorial messages showing, our location on Earth, our place in the galaxy. Edmondson also brings up the interesting concept of distributed cognition, thinking about how we humans use tools and external aids like computers, notebooks, even maps, as literal extensions of our thinking process.
Okay, so like how my phone isn't just a tool I use, it's actually part of how I process information and remember things these days.
Precisely. So thinking about our mind being distributed like that might help us consider how an alien intelligence processes information, or how they might design a message that doesn't rely solely on a single brain or a single language in the way we conceive it. The absolute key, he argues, is to avoid purely arbitrary sequences, unlike, say, the Voynich manuscript, which seems utterly random to us because we lack the key, the context.
All of this really begs the question, though. What kind of intelligence could actually be out there, capable of developing the technology for and engaging in this kind of interstellar communication?
And that's surprisingly hard to pin down. I mean, just defining intelligence is tricky even for us humans, right? The sources mention different definitions, like a general mental capability, or the ability to adapt to the environment, or more complex ideas like Sternberg's triarchic theory or Gardner's multiple intelligences.
But for SETI specifically, the key question is, what kind of intelligence is required to develop interstellar communication technology, like radio telescopes or powerful lasers?
Gary Chick, who analyzes the Drake equation factors in the book, really highlights this distinction. And J.L. Casti suggests there might be specific conditions that seem necessary, at least based on our one example of Earth, for developing that kind of tool-making tech. Things like a free oxygen atmosphere, life evolving on land, manipulative structures like hands, paired with good vision, tool use itself, and complex social structures.
That's interesting. So the implication is, even if creatures like dolphins or octopuses are incredibly intelligent in their own domains,
Which they clearly are.
they might not develop radio telescopes because they lack those specific environmental or physical prerequisites.
That's the potential implication Casti draws from our single data point, Earth. Then you get into the whole debate about convergent evolution. Will intelligence elsewhere tend to evolve in a form somewhat like ours? The humanoids on other planets idea that Robert Peary proposed, based on shared physical constraints.
Or could convergence mean that similar functions or ecological roles emerge, but embodied in wildly different physical forms?
Simon Conway Morris is a big proponent of the latter view. He argues convergence towards certain solutions is common, driven by physics and environmental pressures, but the actual form life takes can be incredibly diverse. And anthropologists in the book, like Coe, Palmer, and Pomianek, seem generally to agree that while convergence happens, it absolutely doesn't guarantee a human-like form will pop up elsewhere.
And then there's the archaeological challenge, which Catherine Denning brings up. Just distinguishing something made by intelligent design, like a deliberately shaped stone tool, from something that just looks like a tool, but was formed by natural processes, like a rock fractured by ice or heat.
Yeah, it's a deeply cognitive problem, actually. We often recognize signs of agency, of something being made rather than just found, sometimes without even consciously knowing exactly how we do it. There's an intuition there.
So our very ability to recognize alien intelligence or their artifacts might be limited by our own cognitive biases and what we expect intelligence to look like, or what kind of traces we expect it to leave behind.
Exactly. Our definitions of intelligence, our expectations about alien form, they're profoundly shaped by our own very specific human earthbound experience.
Okay, so bringing all these different pieces together, the fragmentary nature of potential evidence, the huge challenge of decipherment, the difficulty of understanding alien culture, the biases baked into our definitions of intelligence, how do we even begin to make sense of potential alien evidence if we find it?
Well, Catherine Denning suggests a method she calls cabling, which I think is a really useful metaphor.
Hmm.
It's about weaving together diverse strands of evidence and different types of reasoning, often from different fields.
Like how archaeologists don't just look at pottery, right? They combine it with.
Exactly. She uses the example of Harry Chopek's work on Andean ceramics. If you only looked at the pottery styles, you'd get a very skewed, potentially misleading picture of cultural change in the region. You absolutely need to combine it with environmental data, settlement patterns, historical records if available. Oral traditions is basically everything you can find. That's cabling.
And that method seems essential when you're dealing with massive data gaps, which is precisely the situation we'd be in with SETI. You'd need to pull every discipline and every scrap of potential information together.
It also connects back to that profound challenge of recognizing something you aren't necessarily looking for, or something that just doesn't fit your current understanding of how the world works.
The source uses that great analogy of 18th century scholars in Europe who literally had ancient stone tools, clear evidence of prehistoric human activity lying around. But they couldn't recognize them as tools made by ancient humans because it didn't fit their intellectual framework at the time, which dictated that humanity simply wasn't that old.
And that leads to a really thought-provoking twist on the Fermi paradox. The apparent contradiction between the high probability estimate for extraterrestrial life and the seeming lack of evidence for it.
You mean maybe we do have evidence of ETI or traces of it, but we're failing to recognize it because it doesn't fit our current intellectual context or our narrow expectations?
It's a possibility Denning raises. Just like finding extremophiles on Earth life thriving in environments we previously thought were totally impossible, like boiling vents or under glaciers, makes the idea of life elsewhere seem more plausible. Maybe future discoveries about the universe or even about the nature of life or intelligence itself could shift our intellectual context. It might help us suddenly recognize something that was, metaphorically speaking, sitting right in front of us all along.
And are there any other potential universal connectors people speculate about beyond physics or math that might help bridge these vast differences if contact occurred?
Well, some people speculate about things like mathematics or perhaps music. If music turns out to have some objective structure independent of the human mind, that's a big if. Or even, much more speculatively and controversially, perhaps shared deep spiritual or religious frameworks, though that's highly debated and not something mainstream science usually touches.
This whole deep dive has really shown that the search for extraterrestrial intelligence, SETI, it's just so much more than aiming telescopes and crunching data, isn't it?
Oh, not at all. It really forces a deep dive into human history, human culture, human cognition itself. Archaeology gives us these powerful analogies for reconstructing distant civilizations, but also these stark warnings about how incredibly hard it is to decipher messages without a key.
And anthropology offers frameworks for just beginning to contemplate cultures vastly different from our own, highlighting the dangers of assuming aliens would be uniform and offering these hard-won, sometimes painful lessons from Earth's own history about navigating contact and difference.
Yeah, these fields really challenge our easy assumptions about how easy communication might be, about what intelligence even is, what alien life might look like. They push us constantly to examine our own biases.
It truly feels like an endeavor that has the potential to, maybe uniquely, unify knowledge, bringing together physics, engineering, history, social sciences, maybe even philosophy, in this grand fundamental quest. As Ben Finney noted, a kind of consilience.
It absolutely compels us to look outward to the stars, but also, perhaps even more importantly, it forces us to look inward at ourselves.
So maybe here's a final thought for you, the listener, to ponder, building on those lessons from human history and the immense challenge of navigating difference. If contact, if encounter, is fundamentally about bridging these almost unimaginable divides in time, in space, in culture, maybe even in biology, and if our own troubled history shows such a wide, often tragic range of outcomes from contact, What specific aspects of human culture, of our cognition, of our societal structures are the most crucial for us to cultivate right now? What qualities do we most need to build within ourselves as a species to maximize the chances of a successful, peaceful, maybe even mutually enriching understanding with an extraterrestrial intelligence should we ever actually make contact? What kind of civilization do we need to strive to be?